So, eighth unit, mean value theorems on integral calculus. Today we'll see that on the one problem is there. So, unit 9, mean value theorems of integral calculus. So, in that one 5 marks question we have for solving the problems. Evaluate 1 by n plus 1 by n plus 1, so on up till 1 by 3n. Okay. So this is the seventh question. A sixth question in section A you will get for 5 marks question. So in mean value theorems we have. So first thing is you have to see here the given series is of the form. Series is of the form. Okay, here it is in the form of 1 by n plus r. Here r value is 0, here r value is 1. So here we have to see if the summation, it is starting from r equals to 0 to which value. Okay, so it is of the form 1 by n plus r, which is equals to 1 by n if you take out 1 plus 1 r by n. Okay, so here we can write the series as, the series can be written as, that is summation r equals to 0. Here r value is 0 and the last ending value is 2n. 1 by n plus r. Okay. So this we can write it as 1 by n into summation r equals to 0 to 2 to the power of n, 1 by, and if you take out, already we have taken here, that is 1 by n. So 1 plus r by n. So this is the, whatever the given problem is there, that you can write as like this, 1 by n summation r equals to 0 to 2n. Last value is 2n, such that if you substitute here, you will get the last term as 1 by 3n. So 1 by 1 plus r by n. So therefore, we have to find limit n tends to infinity, summation r equals to 0 to 2n, 1 by n plus r. Okay. This is the problem. It is equals to limit n tends to infinity. That is 1 by n we are taking outside. Summation r equals to 0 to 2n. 1 by 1 plus r by n. Okay. So it is equals to limit n tends to infinity 1 by n summation r equals to 0 to 2n f of r by n. Okay. So where f of r by n is equals to 1 by 1 plus r by n. So yeah, whatever f of r by n is there, this is our f of r by n. So it is equals to, here r by n we are taking it as x value. Okay, here whatever r by n is there, that value is x we are taking. So if you substitute that as x, let f of x equals to, so 1 by 1 plus x. Okay. So since r by n is equals to x. So whatever here r by n is there, that value we are taking it as x. So therefore the given series is written as 1 by 1 plus x here. And we write here whatever this term is there, the term as limit n tends to infinity 1 by n summation r equals to 0 to 2n 1 by 1 plus r by n is equals to, this is 0 to 2 f of x dx. So what is our f of x? F of x is, that is 0 to 2 1 by 1 plus x into dx. Okay. So how you are getting these two limit values, that is upper limit and lower limit, as 0 and 2 means, here you can write, so r by n is equals to x. Okay. Differentiate with respect to x. So with respect to r means, here r value is 1. So you will get this as dx equals to 1. R value is 1. So we'll write it as 1 by n. So dx equals to 1 by n. So that's why here 1 by n is there. No, that value you are writing as dx. Okay. And here the limit values, whatever are there, we'll convert it as taking r value is equals to, what is our value? 0. So when r value is 0 implies we'll get, that is x is equals to 0 by n is equals to 0. And next, when r equals to 2n, that is x equals to 2n by n. So n will get cancelled, so we'll get it as 2. So like this, we'll get the limit values as 0 to 2. Okay. So now when you do the integration of 1 by 1 plus x, it is in the form of 1 by x dx. So integration of 1 by x dx value is log x. So it is equals to log, our x is 1 plus x and limit values are 0 to 2. So when you substitute upper limit and lower limit, that is log of 1 plus 2 minus log of 1 plus 0. So it is equals to log 3 minus log 1. It is equals to log 3. Okay. Since log 1 is equals to 0. Answer for this, whatever the mean value integral is there, no, for that when you do the series with the help of this, whatever the steps are there, you will get it as log 3 as the answer. Okay. So next, so this is about the 8th unit. So example, more problems are there in your test tube. So try to solve those example problems. And last one, last topic in 4th block. So in 4th block, 10th and 11th unit, you have the all theorems are there. So yesterday I have told the important theorems in 10th and 11th unit. You can see those theorems. And last unit is unit 12. So unit 12 is about the power series. Last unit is about the power series we have. So it is related with infinite series. So the series which is in the form of summation n equals to 0 to infinity. the series summation n equals to 0 to infinity an x minus x naught to the power of n is called power series in x minus x naught. Okay, so the representation of power series will be in the form of summation n equals to 0 to infinity an x minus x naught to the power of n. Okay, if x minus x naught value equals to capital X, then above series, so above series we can write it as summation n equals to 0 to infinity an capital X to the power of n. Okay, here x minus x naught value if it is equals to capital X, then we can write it as summation n equals to 0 to infinity an x to the power of n. So usually problems will be asked in this form and also in this form will be asked. So if in this form it is asked, here x naught value you have to see. If directly it is given, this x naught value is 0. Okay. So, so we will see one more definition you have in this. It is the radius of convergence and interval of convergence. We have two concepts in this. So interval of convergence means first we will see what is radius of convergence. So radius of convergence means suppose if we have an x to the power of n is given as a series, is a power series, and limit n tends to infinity mod of an plus 1 by an. When you do like this, if you'll get the answer as some any finite non-zero number, that value will take as it equal to q. Okay. Then radius of convergence equals to radius of convergence is r equals to 1 by q. Okay. So whatever the q value you are getting, if you do as 1 by q, that value is called as a radius of convergence. It is small r. Okay. R equals to 1 by q. Okay. So in this only, if you see what is interval of convergence. Interval of convergence is, so whatever the r value you are getting it as, some value you will get, no, that value. If you will write it as x naught minus r comma x naught plus r, this is called as interval of convergence. Or we can write it as minus r comma small r. Okay. So these are the definitions which are important in 12th unit. So the series, whatever it is in the form of both this and this, some problems will be of this form and some problems will be of this form. So after taking the an value, if you find an plus 1 and if you do the mod of that and you find the limit, whatever the value you will get, that value is called as a radius of convergence. And with the value of radius of convergence, we can find interval of convergence. Okay. We'll see one example problem on this. So we'll see problem one here. So first problem is, that is summation n equals to 0 to infinity. It is x by 2 to the power of n. Okay. This is the given series we have. It is summation n equals to 0 to infinity x by n to the power of n. So you can write this as given summation n equals to 0 to infinity x by 2 to the power of n. Okay. We can write as summation n equals to 0 to infinity 1 by n, 1 by 2 to the power of n. If you split out this one, you will get it as 1 by 2 to the power of n into x to the power of n. Okay. So it is in the form of an x to the power of n. Okay. Where an is equals to 1 by 2 to the power of n. Okay. So an plus 1 is equals to 1 by 2 to the power of n plus 1. So we have limit n tends to infinity mod of an plus 1 by an. So it is equals to limit n tends to infinity. So our an plus 1 value is 1 by 2 to the power of n plus 1 by 1 by 2 to the power of n. Okay. So this you can write it as limit n tends to infinity 1 by, that is, if you take this one to the RS, into to the power of n will come above and 1. So this is equals to limit n tends to infinity. Whatever n plus 1 is there, 2 to the power, if you take into numerator, it will become 2 to the power of minus n minus 1 into 2 to the power of n. Okay. So this is limit n tends to infinity mod of 2 to the power of minus 1 plus n. So this n and minus 1 will get cancelled. So we will get it as limit n tends to infinity 2 to the power of minus 1. So it is equals to limit n tends to infinity 1 by 2. So it is value is constant of any limit will be the same constant value. So you will get this as 1 by 2. So this 1 by 2 is equals to q. So q means this is the radius of convergence, no? So the radius of convergence equals to r equals to 1 by q. So our q is 1 by 1 by 2. So it is equals to 2. So we got the radius of convergence as r equals to 2 we got it. So here you can write, and even if you see the interval of convergence, it is interval of convergence is, here it is in the form of x, capital X to the power of n, no? So interval of convergence is minus r comma r. So what is our r value we got? It has 2. That is minus 2 comma 2. Okay. So whenever the problem is given, you have to check what is the an value, and after that you have to find an plus 1. When you do the limit of that, whatever the value you will get, that will be the q, and the radius of the convergence is 1 by q, and interval of convergence is minus r comma r. Okay. So if you see one more example problem, it is find the interval radius of convergence and also interval of convergence of x to the power of n by n factorial. Okay. Find radius and interval of convergence of power series summation n equals to 1 to infinity x to the power of n by n factorial. Okay. So here we have x summation we have taken if it is x to the power of n by n factorial. So this we can write it as given 1 to infinity x to the power of n by n factorial. This we can write as summation n equals to 1 to infinity 1 by n factorial into x to the power of n. Okay. So where n value is, that is an value is equals to 1 by n factorial. So 1 by n factorial we have. So an plus 1 is equals to 1 by n plus 1 into factorial. Okay. So now limit n tends to infinity mod of a n plus 1 by a n is equals to, it is limit n tends to infinity. So what is our a n plus 1? It is 1 by n plus 1 into factorial by 1 by a n value is 1 by n factorial. Okay. So now this is equals to, if you interchange the numerator and denominator, you will get it as limit n tends to infinity 1 by n plus 1 into factorial into n factorial by 1. Okay. So this is equals to, here n plus 1 factorial, you can write it as limit n tends to infinity 1 by n plus 1 into n factorial. Okay. Down you are unable to see. Oh, so this one I will write above. So it is equals to limit n tends to infinity 1 by n plus 1 into n factorial into n factorial by 1. Okay. So this n factorial and n factorial both will get cancelled. So you will get it as limit n tends to infinity 1 by n plus 1. Okay. So whenever we'll take this as limit n tends to infinity 1 by n, if we'll take out common 1 plus 1 by n. Okay. So this is 1 by n tends to infinity, no? So here whenever you will keep here the value as infinity, it is 1 by infinity plus 1 by infinity means this is 0. So 1 into infinity means this is infinity. So you will get this as 1 by infinity which is equals to 0. Okay. Or else you can write like this also. 1 by infinity into 1 plus 1 by infinity. So it is 1 by infinity into 1 plus 0. So it is 1 by infinity, which is equals to 0. Okay. 0, and it is equals to q. Okay. So now radius of convergence, what we have? Radius of convergence r equals to 1 by q. So that is q value is 0, no? So 1 by 0 means it is equals to infinity. Okay. So interval of convergence is minus r comma plus r. So it is equals to minus infinity comma plus infinity. Okay. So like this we have to find the problems for the power series. So you can solve some example problems here. X to the power of n by n factorial. Okay, 12.3.5 page number. It is in page number 144. So check your progress. It is there. And one more example problem we have. So you can see all the exercise problems wherever it is there, and you can solve those. Many exercise problems are there. So here an value is directly it is given in some problem x naught value also will be there. So we'll see one problem on that. That is determine the radius of convergence of the power series summation minus 1 to the power of n root n x minus 1 x minus 5 by 3 to the power of n we have. Okay. So here we need to find the radius of convergence and also interval of convergence. Okay. So the problem is almost all is there.
ఎందుకు కన్సిడర్ చేయడు అడుగు ఇది ఓకేనా ఇది
అందుకే ఇవన్నీ మనం దాంట్లో
వాళ్ళు తీసి మళ్ళీ నీకే సెండ్ చేయాలి
అది క్లియర్ వస్తుంది కదా.
ఏదో ఒకటి చెప్పడానికి రెండు వచ్చినాయి రావు.
Okay, this is the problem. Summation minus 1 to the power of n into root n x minus 5 by 3 to the power of n. So if you see, this is in the form of x minus x naught to the power of form. Okay. The given series is of the form summation that is a n x minus x naught to the power of n. Okay. X minus x naught to the power of n series of the form this one. So where an is equals to, so here if you split out this one, so where an is equals to minus 1 to the power of n root 10 by 3 to the power of n. Okay. And what is our x naught value? And x naught is equals to 5. Here whatever the value is there, no, x minus x naught. So x naught value is 5 here. So first we have to find an value with respect to of the limit an plus 1. So this one to the power of n is there, no, we can use the Cauchy's ratio test, that is limit n tends to infinity mod of an to the power of 1 by n. Okay, we have studied in 6th unit with the help of the Cauchy's root test. Okay, so it is equals to limit n tends to infinity. So if you will take out this minus 1 to the power of n, whenever you will write in the mod, it will become that is minus 1 to the power of n root 10 by 3 to the power of n by 1 by n. Okay. So it is minus 1 will become it as a positive one. So you will get it as n to the power of 1 by 2 into n. Okay. By 3 to the power of n into 1 by n. And it is equals to limit n tends to infinity. Okay. This n and will both will get cancelled. You will get it as limit n tends to infinity n to the power of n by 2 you will get n by 2 by 3. So here n value what we have, infinity we have. So infinity to the power of infinity by 2. So whatever the value is there, you will get it as 1. So it is equals to 1 by 3. It is equals to q. Okay. So when you substitute the n value as infinity, there you will get infinity to the power of infinity by 2. So okay. So that value will be into 1 by n. Now this is 1 by n. So you will get this as 1 by 2n. Okay. So 1 by infinity means how you will get this? If you have any confusion, you can see here. It is equals to infinity to the power of 1 by 2 into infinity into 1 by 3. Okay. So this value is equals to 1 by 3. So 1 by infinity means 0. Infinity to the power of 0 means that value is 1. So 1 by 3. 1 by 3 is equals to what? Q. So Q we got. So the radius of convergence is So hence radius of convergence is r equals to 1 by q. So q value we got 1 by 3. So it is equals to 1 by 1 by 3. So the value is 3 here. Okay. The interval of convergence is what is the interval of convergence? X naught minus r comma x naught plus r. So what is our x naught value? X naught value is 5 before 1. Okay. So 5 minus 3 comma 5 plus 3. So it is equals to 2 comma 8. So the interval of convergence is 2 comma 8. So whenever an value is given and also x naught value is given, like this you have to solve the problem. So by this problems in 12th unit we are completed. So we'll see the important questions in from first block, second block. Page number 7. So page number 7, 1.2.11. So you have the problem. So this is the 5 marks question you will have. It is a triangle inequality. 1.2.11. Well, 1.2.11. Okay. Page number 7, 1.2.11. So page number 7, 1.2.11. Next, page number 8. It is 1.3.3. One point 4.9. Page number 10. Page number 11. 1.4.11. Okay. 1.5.21. Page number 25. 2.13. Next 26. 2.2.14. 27. 2.2.15. For 29. 2.3.11. And page number 32. 2.4.3. Next in third unit. 39, page number 3.3.7. 3.3.8. 3.9. Okay. Next page number 14. 3.3.12. This is very important. Sandwich theorem we have. 43. 3.4.4. 44. 44, page number 3.5.1. 3.5.1. Okay, this is also important. That is a Cauchy's first theorem we have. So block 1, these are the important questions. Next in block 2. Page number 58. 4.3.12. 4.3.12. And 59. 30. 62, page number 5.1.1. Okay. Five point 1.14. 59, 5.2.1. And 5.2.2. 75.2.3. 5.2.5. This is about the fifth unit. Next we have the sixth unit. Sixth unit 75. 6.2.6. Next 76. 6.2.7. 79. 6.3.2. Okay. And 80. 6.3.3. And 81 page number. Okay, first one, a gamma. 82 page number. MEQ question 6.6. Okay. In 6.6, 1, 2, okay, 1, 2 problem 6.6. So block 3, already we have seen some problems. Already I have given the important questions there. So these are the important questions in block 1 and block 2. Okay. So next week we'll see some more important questions in third and fourth block.